This is Mrs. Robertson, and I know that many people are now listening to my videos from all over the Franklin Township. And now we are on page 827, compare populations. Kids, let's quiet down. Page 827, we will be comparing populations. Chapter 10, Lesson 4. Real World Link. Here we go. Mr. Singh surveyed the students in his first period gym class to find out how many times they exercised this month. The box plot below shows the results. All right, kids, I want you to answer those questions. Minimum, maximum, range, first quartile, third quartile, and the interquartile range. We did not talk about that. I will answer that one with you in just a moment. Yes?
What book is this? The first one?
This is your math book.
We have two.
Page, it's the one that has, it's the second math book. 827 is in the second one. Yes.
Can I sharpen my pen?
Yes, you may. All right, so the minimum, 0. Your maximum, 30. 30 minus 0 is your range of 30. Your first quartile is where the box begins, 5. The third quartile is where your box ends, 20. Your interquartile range is the size of your box. 20 minus 5 is 15. So once again, to get your interquartile range, the size of your box, 20 minus 5 equals 15. Are there any questions? Yes.
So you just do the third quartile minus the first quartile?
Yeah. That's what it is. What is the median, and what does the median represent? The median is 10. And it represents half the students exercised more than 10 times and half the students exercised less than 10 times. So half students exercise more than 10 times and half of the students exercise less than 10 times. Any questions on that? Okay, let's turn the page. 828. Compare two populations. A double box plot, this means you have two box plots, consists of two box plots graphed on the same number line. A double dot plot consists of two dot plots that are drawn on the same number line. You can draw inferences about two populations in a double box plot or double dot plot by comparing their centers and variations. I almost feel like I'm reading a Dr. Seuss book there. The centers and variations to use are shown. Okay. Both sets of data are symmetric, then you use a mean. Symmetric means they're well balanced, okay? Neither set of data is symmetric, then you use the median. Only one set of data is symmetric, then you use the median. All right? Measure of variation, mean absolute deviation when both sets of data are symmetric. Interquartile range whenever it's not symmetric. And when only one side is symmetric, then you would use the interquartile range. Now let's look over here. If I were looking at, these appear to be symmetric, all right? The only thing that's not symmetrical is where the median is. See, this is symmetric. This is not symmetric. Symmetric means everything is in nice, neat order. Every piece is about the same size, okay? Here, this is not symmetric because this piece is smaller than that piece in order to represent the data. All right, let's go to example number 1. Yes, Mitchell. No, but notice how they are the same. Like this one they're both the same. Now, if this whisker was really long, then it would not be symmetrical. Okay? Now, in number 1, Casey surveyed a different group of students in her science and math classes. The double box plot shows the results of both classes. Compare their centers and variations. Write an inference, that means a statement, you can draw about the two populations. Here we have, how many times have you posted a blog this month? Well, in math class, there were 30 students, and or 30 times was the most number of times someone posted a blog. You can tell that in math, there aren't quite as many. There's a wider range of 5 to 20. But in science class, more people are doing blogs because it's in the range of 15 to 25. It says neither box is symmetric. Use the median to compare the centers and the interquartile range to compare the variations. Now, when you look at this one, you're going to say, but Mrs. Robertson, that box is symmetric, but what keeps it from being symmetric are the whiskers. All right, someone had asked earlier, this is not symmetric because this whisker is much longer than that one. This is not symmetric because this is over to the left quite a bit. So when that happens, you use the median. You don't use the mean. Yes?
How are the boxes the same?
I didn't say that the boxes aren't the same either. Okay, I just was talking about what made the box look symmetric and not symmetric, or the box plot. Yes?
How does the whiskers not make it symmetric?
The whisker, this whisker is longer than this whisker. So it's not symmetrical. To be symmetrical, you want your whiskers to be the same size.
It's literally the same on both sides.
Are very close to being the same size.
Like cut it in half, that would be the same.
Right. So, your measure of center you're going to use in this data is the median, and your measure of variation is going to be the interquartile range. Now, overall, the science students posted more blogs than the math students. The median for the science class is twice the median of the math class. The median is 20, and in math class, the median number of blogs is 10. There is a greater spread of data around the median of the math class than the science. The spread of data, it talks about mainly the box. The box is larger for math, so the spread of the data is larger than what the spread of the data is in science. Any questions? Let's go to the next example, part A. Here, we're going to do this problem. It says the double box plot shows the costs of MP3 players at 2 different stores. Compare the centers and variations of the 2 populations. Write an inference, that just means a statement, you can draw about the 2 populations. Okay, so you're looking at that. Are they symmetrical, kids? No, so you're going to use the median. And a statement that you could have for this, for your answer. The median price at Electronics World is $10 more than the bargain basement. That's an inference. That's a statement. Another statement. The interquartile range is the same for both stores. The size of the box for both stores is $10. Generally, MP3 players are more expensive at Electronics World. So Electronics World, they cost more than they do at Bargain Basement. Okay, now let's go and look at example number 2. Here we have a double dot plot. The double dot plot below shows the daily high temperatures for 2 cities for 13 days. Compare the centers and variation of the 2 populations. Write an inference you can draw about the 2 populations. Well, when it says, I'll just read what they have here instead of giving my own opinion first. It says both dot plots are symmetric. Look, they both sort of go up and down. So if they're symmetric, we're going to use the mean to compare the centers, and use the mean absolute deviation rounded to the nearest tenth to compare the variations. So our mean is 81 for Springfield and 84 for Lake City. Now kids, you use the same numbers for both of them. You're going to say there aren't numbers for this one. That's because this is 88, 87, 86. The numbers are in the same spot for Springfield as they are for Lake City. All right, question. Okay.
Why would you want to find like the interquartile range of the mean absolute deviation? What would you do?
Okay, on the previous page, measure of variation. That's when you use these. The measure of center, mean, median, or mode are measures of center, and measures of variation are mean absolute deviation and interquartile range. Yesterday we talked about the interquartile range is the size of the box, okay? And we'll talk more about mean absolute deviation because I don't think we've talked about that in this class, have we yet? I'm going to go over that. I'll check to see if that is on your test. One year it wasn't on there, so I'm going to double check to see if we need to know that. It might be an 8th grade standard as opposed to a 6th grade or 7th grade standard. All right, so here are the answers. It says both dot plots are symmetric. We'll use the mean. It says while both cities have the same variation or spread of data about each of their means, Lake City has a greater mean temperature than Springfield. Here we go. Mean absolute deviation. It's right here. What is that? To find the mean absolute deviation, you find the absolute values of the differences between each value and the mean. Then find the average of those differences. Right now we're not going to focus on that, but that's the definition. And when I want you to know more about it, I'll give you a specific lesson on it, okay? All right, let's go on now and look at part B. Is this one symmetrical, kids?
No.
So what would you use? The median, right. So your inference here on this one, you're going to use the median. And here is the rest of what they had. The median of Pedro's data is 35.5. This one's Pedro's. Emails with an interquartile range of 2.5 emails. The median of Annika's data is 32 emails with an interquartile range of 4 emails. There is a greater spread of data around Annika's emails, but Pedro's data centers around a higher number of emails. So, you normally would expect him to have more emails, which he seems to have more emails. Questions real quick. We have a lot to do in a short amount of time. Yes?
How would you find the interquartile range of the quartiles on the
You have to do a box plot. Now, I could make you do the box plot on this, but we really don't have time right now. So yeah, interquartile range is the size that the box is. See right here? The interquartile range would be 80 minus 40, which is 40. So the interquartile range for dance camp is 40. The interquartile range for music camp is going to be, it's about 65 minus 45. So that one would be 20. Quick, yes?
What is the 0.5 in Pedro's emails?
That's because they added them all together and divided by however many they have. Yes.
So,
Just a
to
second.
find the median, would you do the number of dots in, like, from Mr.
Okay.
or the numbers?
Okay. You count the, okay. You could put the numbers down. Let's just do this one. To find your middle number on a dot plot, 1, 2, 3. Then go back to the bottom. 4, 5, 6, 7, 8, and you end up at 32. All right? For hers is 32. Now, Pedro's was 35.5, so it must have been in between 35 and 30. He must have had, it must have fallen in between 35 and 36 to get 35.5. It's probably this one and this one where they had two middle numbers.
No, it isn't. It's 16.
Not for your median, because these are all the same numbers.
3.
So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It was this one here because you go, but yeah, so they're even numbers, so it would fall in between there. Yes.
So when we write down the answer, you just want us to say median, or do you want to use the median and say like the median of both of them?
Okay, it wasn't specific. It says write an inference, so write a statement. You have to write a statement comparing these two. So there are several statements you could use to compare these. All right, and I don't care which one you would do. Now, but I will say that if you're going to compare them, I guess it does matter. When it's not symmetrical, you use the median, okay? When it is symmetrical, you use the mean. So it does make a difference. This is not symmetrical, so when you just describe the data, you're going to use the median. When it is symmetrical, you'll use the mean. Now let's go on to example 3. The double box plot shows the daily participants for 2 zip line companies for 1 month. Compare the centers and variations of the 2 populations. Which company has the greater number of daily participants? Okay, now, see this thing right here? That's a big outlier. When they are off when they're not even included on a box plot, and it's way out here, it means it's a really big outlier. They didn't want to include it because it would mess up the data too much. It must have been a day where they had a whole bunch. This company had a bunch of kids from a school show up or something. Could be. All right. So which company has the greater number of daily participants? It says it's not symmetrical, so we're going to use the median. Tree Toppers Tours is 70. Zip Adventures average is 50. The interquartile range, or the size of the box of this one, is 30. The size of the box for that one is 20. Okay, so then they just did a comparison. Now let's go on to the next page. Example 4. The double dot plot shows Jada's and Angel's numbers of hours worked in 2 weeks at their part-time jobs. Compare the centers and variations of the 2 populations. Who typically works the greater number of hours in a week? All right, so we look at this. This is Jada's. This is Angel's. The distribution of Jada's number of hours is symmetric, while the distribution of Angel's number of hours is not. Notice she has a few more on this side than she does on that side. This one, it's a perfect symmetrical one that's well balanced. This one, hers is not balanced. So we use the median. They both have the same middle number of 8. And if you did the box plot, you would find out that the interquartile range is 2. So let's go on. It says the median and interquartile range for both sets of data are the same. However, the interquartile range for Angel's number of hours worked is the difference of 10 and 8. Once again, you have to do the whole box plot to find the interquartile range. So Angel typically works more per week. Now let's look at letter C. Yeah, you got a question? When we're done with this. Okay, the double dot plot shows Kareem's and Martin's race times for a 3-mile race. Compare the centers of variation of the 2 populations. Well, Kareem's is symmetrical. Is Martin's symmetrical? No. So we're going to use median. So for the answer on this one, you're going to use your medians. So you compare the medians on this. Let's see, Martin's is 18, or Kareem's median is 18. Martin's median is, it's going to be 17. All right. And then if you made the box plot, the size of the box plot would be the interquartile range for Martin's would be 4 minutes. Interquartile range is 4. IQR is interquartile range. Whereas the interquartile range for Kareem's is 2. All right. Which runner is more likely to run a faster race? By looking at this data, which runner is it? Martin. Martin is more likely to run a quicker race. Okay, let's go on to the, there's Martin's answer there. Now let's go on to the next page. There's a lot of reading to this lesson, kids. So for the guided practice, the information is symmetrical. In number 1, here we need to see both of them. They both are symmetrical. All right, so since they are both symmetrical, you're going to find the mean. Now, to find the mean, you have 2 14s. I'm going to do 5th period first. You have, 1 14, 2 15s, 2 16s, 3 17s, 2 18s, 2 19s, and 1 20. All right, so add them all together, and then you're going to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you add them all together and divide by 13. That will give you your mean. All right. Another way of doing that is for the mean, since you don't have to do the median, 14, 15. 3 15s will equal what, 45? Here we have 16s. 1, 2, 3, 4 16s. So if you have 4 16s, that'll give you 64. 3 17s gives you a 51. That's an 18. So here you would add those all together. 14 plus 45 plus 64 plus 51 plus 18 equals 192. You don't divide it by 5. You're going to divide it by however many dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one has 12 dots. And this one I said had 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, that one has 13. So 192 divided by 12 equals 16. So the mean for second period equals 16. The mean for fifth period equals, you have to add those all together and divide it by 13. All right? Which when you do that, you get 17, kids. Okay? So the inference that you can do between the populations would be fifth period scores centered around a higher value. However, the variation is also greater, which means the scores were more spread out in fifth period. They had the higher mean, but their scores were more spread out on there. So that would be the definition for that one. Now let's look at number 2. In number 2, you are comparing box plots. On which road are the speeds greater? Well, when you look at this one, the speeds recorded on Hayes Road are greater. Hayes is this one. And are they symmetrical? Are these graphs symmetrical? The first one is, but the second one's not, so we compare the medians. I always like it when they have the box plots because it's easier to do the interquartile range. So we're going to compare the medians. Hayes Road median is 55, and Jefferson's Road median is 45. So Hayes Road median is 10 greater than Jefferson's Road. All right. Then when we compare the interquartile range, the IQR, the size of the Hayes box, the interquartile range is 50 minus 6 or 60 minus 50. Hayes Road equals 10. And Jefferson's Road, 55 minus 40 is 15. So the interquartile range is greater in that. Any questions? Okay, so for your homework tonight, what I want you to do, number 1, number 2, let me look at number 3. We're not going to do number 3, so do 1 and 2. We're not going to do number 4. Okay, I want you to do 9 and 10. They both already have box plots. 9 and 10. Okay? So you just have 4 problems. 1 and 2, 9 and 10. And the only one with the dot plot is number 2.
So you have to draw a box plot in order to get the interquartile range?
Yes, because they're not symmetrical, yes. That's the only one you have to do that to. Okay? So, let's get going on this. No, this is something we need to do by ourselves today.